Hello and welcome back to the development of the Feersum scheme compiler. So a bit of a bug fixing stream today. So I'm going to start by going over what went on in the last stream and then we can look at what we're going to do today. So in the last stream, well, what did we get up to? In the last stream, I was looking at the binding of let forms. So in Scheme, you can introduce scoped variables that are within a specific, scope. So a given form, the let form has like a list of definitions and then a list of its the body, which is the different expressions. And in this case, B and C are only visible inside the body of the let form. So they're a bit awkward, and we had to rewrite the way that scopes worked to be able to get that to work. But that's all done now. We can now define a let expression either inside a lambda. You can nest them. They work at the root level as well. And one of the knock-on effects of that is that expressions at the root could be reading and writing from global variables, or they could be reading and writing from locals. So the way that the expression evaluation works in this compiler is that we have like this synthesized script body method at the root. So you can actually end up with local variables in that script body now. But we still have one open issue on the repository about the way that if bindings affect the hoisting of things into captures. So there's an awful lot of work that went on to make captures work. So we walk through the tree in the binder, and as we walk through the tree, so let's have a look at this case. So in this tree, we would walk it like we'd go and bind the define node, and in the define node we bind the letrec node. We'd go in and we bind this initialization here, and then we bind this initialization here. And the problem we've got is that we see that even here should be captured, and so we move it into the environment. And when we actually end up, so that means that this when we initialize it down here, we write into a local, but here we're reading from an environment. And we actually, when we end up going to generate code for this, we end up putting with the actual hoist of where we move. The idea is that as we flow through the tree, we're supposed to notice when things move from being locals to into the environment, and we put the hoist expression, and we do that effectively just before this call to even. But that doesn't really work in cases like letrec, and it also doesn't work in ifs and things like that. It's just inherently flawed. So the plan for this stream is to fix this bug by, well, we'll see how far we get. But the 3-step plan is effectively stop environment allocation when we do the bind. So just make the bind responsible for working out which variable references go to which storage locations. So it's fine to say that a captured storage location is still the local variable at that point in time. We just keep a track of who's captured what, and then we have a second pass that then walks the bound tree, and it goes for everything that should be moved into the environment. It rewrites those expressions so that they now reference the storage location in the environment rather than the original local. And then That should make the job of the compiler easier because it doesn't have to do like ad hoc on-demand hoisting, because everything will be rewritten to point to the environment location. So we can just rely on the fact that instead of it trying to write to local like 3 or something, it's just writing to the environment slot we've allocated for that instead. So local 3 will never get used. And then stretch goal is to actually do some cleanup so that we don't have unused local variables. But for the first pass, I'll settle for it working, just reading and writing for the environment. So the place I'm going to start with for that is in the binder. So in the binder, we have the binder context with our scope on it, and scope lookup mainly happens through the parent lookup and lookup and capture. So normally when we've got a variable, we've got an identifier, we look it up in the binder context, but we do lookup and capture. So lookup and capture could either find it directly, or it could do a parent lookup. Yeah. So what we're doing here is, if we look it up and it needs to be captured, then we allocate this environment slot for it. And then when we do the parent lookup, if we were calling in from a parent lookup, we'll allocate the captured for it at some point in the future. So the plan is that when we call lookup and capture, we won't allocate the environment slot. We just keep track of the fact that it needs to be captured. So we can get rid of the call to get next environment slot, and we can not rewrite that entry. And I don't think we want to rewrite the environment size either. And then that obviously becomes just returning the value, because we don't need to do anything special with it. So sum becomes it's just going to be sum entry.value. Just get rid of the whole clause. And I believe that actually ends up being the same as the scope.lookup. Scope.find down here. And in this case, we can do the option or else with that we're doing here. And I think this is telling us that lookup and capture is actually just lookup, try find binding. Because context scope ID or else with, I think we can just make Let's make try find binding the main recursive method here. That can be try find binding. So here we're making the decision now whether or not to capture something, and it isn't the case that we haven't wrapped arguments or locals in anything yet. So we'll do that there. So if we got captured value and argument or local, we can leave the environment in there. We should never get an environment value. So let's see how much that's broken. Three things. I don't know if that's a good thing or a bad thing. It's not a huge amount, this. Actually, depending on this. Yeah, unexpected storage in capture chain local 0. So basically we're getting errors, internal compiler errors, because the bound tree is now no longer something that we can lower, because we expect at the end of our capture chain we're going to get an environment location to read or write from. So the environment size. I don't know whether or not we need to keep track of the environment size here. So in the binder context, we have env size. We'll leave that for the time being, but I suspect that we can get rid of next env slot because nothing is using it. We set it to 0. We set next, where we call get next env. But do we call get next env? I think that's telling us that we don't reference that anymore. So we'll get rid of the environment slot, and I think the environment size can also go, because I think the only references to that are when we mark the environment as being used, and later on when we tell the binder what the environment size is. But we can leave that for the time being. That's going to effectively tell us a little bit that whether or not a lambda actually captures something directly or indirectly. So that'll either be none or some 0 now, because we're never actually making the environment size bigger. Okay. So we can get rid of the initialization of the environment slot if we're not going to use it. Yeah, that's dangerous. Then we need to go and add something new. Do we want this to be a whole new pass? So what does bind do? Bind has our bound expressions and stuff. I think we can have something that comes after the binder, and we'll do that all in one new file. Add file below. We're going to call it invalid. I'm wondering whether or not lower would be a better name for this for the time being, because we're effectively taking the high level bound syntax tree and rewriting it. So the compiler will start off lower with having a pub it's just have a single public function of lower, which takes an AST and it's just going to return the AST for the time being. I don't think this needs to worry about generating diagnostics or anything, because we've already bound the tree, so anything that should have or could have gone wrong will hopefully have gone wrong then. Lower bound tree to form better suited the emit phase. Then in compile we can have compile at the moment does bind, and then if there was any errors it does emit. So I think the first job here is to make bind return something a little bit more sensible. So we've got this 3 tuple here. So I think we'll just make this back to, say if this was a single structure, then it'd be easier to take that, pass it through our lower pass, and then back onto emit. So that's what we're going to do now. In the binder, we'll introduce a new type, bound syntax tree. I think that's what it's usually called. It's going to have a root which is going to be of type bound expression, and it's going to have diagnostics, which is well, we'll see what bind returns. What does bind return? Bind returns bound expression int diagnostics list. Yeah. Bound syntax tree diagnostics list and locals count, which is an int. That's diagnostic list. Root type returned by the binder. Someone at work's added a check to make sure that documentation comments end with a piece of punctuation. So I'm getting into the habit of putting a full stop at the end of my comment. So then in this case, we run the binder, and then what we say, let's bound equals run the binder, and then we return root is the bound. We have local count is context dot local count, and diagnostics take. Good. That pluralization, eh? Right. So now we've broken the compiler because this is expecting a single thing. And if we say bound.diagnostics, there we'll return bound.diagnostics. And here we want to say bound, and then we need to change emit. And the interpreter is broken as well for the same kind of reasons. So we do bound, and then diagnostics has errors. If not, we can just execute the root. I don't really know why we're doing it that way around in the interpreter, but as I keep on saying, that file just needs to find its way to the bin. Bound.root bound.locals. No, I think I want to go back to that emit, taking just the bound tree, and then we can say where we reference bound. Where do we reference bound? It's going to be in the lower body. I'm going to say root bound.locals count. That's a little bit nicer, and that means that in the compile method, no? Compile. In here, we can change this to bound pipe to lower pipe to emit. Which we need to open. If that's all we're doing, that's all we're doing. Probably don't need to open it for that. So this is still going to fail, hopefully just those 3 tests. Right. So lower is going to do AST with root equals or lower expression. AST.root. So what we'll do is we'll pass, what's it coupling? Yeah, it will be. Don't worry about it. If we do bind, and then private lower expression actually you can make this a function, and we'll start off with all the different types that we can have. So if I was doing this in an object-oriented language, I would do something like the visitor pattern, but we don't have that, and instead we've got match expressions. So string load. So loads and stores. We do need to rewrite those. For these others up here, I'm going to keep track of these are ones that we just want to do nothing with. So I'm going to do a discard one for those. So it's going to be like rewrite, load, rewrite, storage, store. And this is going to be store, rewrite, storage, and value is going to be lower expression v. So we lower the whatever we've got, option dot map application. We're going to need to rewrite that if sequence and lambda. Null and error we can just leave as well. So all of these can just become a catch-all expression. What's going wrong here? Rewrite storage doesn't exist, and that wants to be something like that. Rewrite the capture environment for it. So I'm going to change this to rewrite expression. Expressional. Because why not? And I could have done that as a refactoring, but I didn't. Rewrite storage. I think rewrite storage is going to also be a function where we take storage ref. So if it's global, actually let's just go find storage ref and copy all of its cases again. So I think a fair number of these aren't going to need rewriting. So if it's a built-in, we don't need to rewrite it. If it's captured, we need to rewrite it. If it's an environment thing, we don't need to rewrite it. Arguments and locals, we don't need to rewrite. It's only a captured thing we'd need to rewrite. So I could have thought about that a bit more. Let's get rid of that. Nope. So if we've got something captured, we need to decide if it's something, if it's an arg, we need to allocate an environment for it. If it is a local, we also need to move it to the environment. If it's a captured, we need to rewrite the inner. Because that's how we're going to walk our way back up the chain. And for everything else, we can just pass it straight back through. In theory, there shouldn't be anything else in these capture chains other than locals, arguments, and more capture references, but it's probably safer. Shouldn't happen. Capture chains should only contain args, locals, captures. And that's quite a long comment, so let's break that onto its own line. Oh dear. I killed that in the wrong way. I used the Emacs bindings and accidentally moved it into some place where apparently I can't get it back from. Undo. And oh dear, not having a good day. So if it's an argument, what are you complaining about? Yeah, but what's this catch-all down here? The first branch here has unit. Yeah, you probably got yourself confused there. So let's just pause the rewrite storage. Storage location to move captured values to the environment and a full stop. And down here, I'll finish off this match expression first. So we're expecting an application and arguments, and we are going to, let's do fail with not implemented, and then we can just copy, so we can simply copy and paste for everything that isn't implemented. And then if, I think officially the scheme docs call this condition consequent and else or something, but we don't have the word else available to us. Sequence of explorers. Writing compilers, you get to learn a lot of shortenings of things like class and that kind of thing that don't clash with the identifiers found in languages. Like the Ruby compiler uses class with a capital K all over the place so that things don't get messed up. I think it's the Ruby compiler. So we've got formals. There's a lot. There's a lot of things here. What was int? It's the first int. Yes, locals. And then the next one is storage ref list is the captures. And then it is the env, and then it's the body. At least if I get that right, I won't have to rewrite it in a bit. Rewrite storage. Yeah, well, it's not actually going to be unit in a minute when I fix it up. Why don't you have one of those, and you can have one of those as well. Now we recognize what's going on, and it even roughly type checks. I'm expecting a whole load more tests to fail now, because actually I'll be surprised how much of the testing actually passes, given that we've basically just broken the entire compiler, because this rewrite doesn't handle any of the interesting cases. $51. That means 115 things aren't to do with actually executing code. So we're going to need some kind of context for this. Oh. Lower. Capture conversion context. Good old CTX, yet another shortening of a word. And what is a capture conversion context going to have in it? Well, I think it's probably gonna have nothing interesting in it for the time being. What we're going to want here is a list of parent contexts, so that every time we encounter a lambda, we can create a new context, rewrite the body of the lambda with a parent pointer that points back up to the context it was coming from. And that way, when we get a capture chain, we can rewrite the storage in the parent context. I think that's what we're going to do. So first things first, we'll have parent, which is going to be an option capture version context option. So, because obviously the root one is not going to have a parent. Let's make rewrite storage take a context, rewrite expression take a context, and then we'll say let context is parent none. Rewrite expression. Rewrite expression is going to take that context. I think that's an out of date one. Rewrite storage wants to take the context. Rewrite expression takes the context, but we need some... Right. I think I can probably get rid of these. Yeah. Rewrite storage is going to take the context. So now we're passing the context all the way up the chain. We're rewriting we need to match this. If we have a parent, we will rewrite the capture in the parent. If we don't, we will fail internal compiler error. Just the right amount of R's, please. Capture chain does not match nesting, I guess. So yeah, we're going to have to do something to have a map in our context so that we know where to move, which environment slot to move these to. What's the arg is arg of int, local of int. So I think we could do like, we'd have a mapping on the capture conversion context. And the mapping would say it's going to go from storage ref to storage ref. And we do like match. Or could we just do context dot mappings s. So I did mean to do dot. So this is basically rewriting storage correctly now. But the bit that is not implemented is working out what we need to move into the environment. So I think we can finish this bit off. So if it's an application, we'll do application rewrite expression context app and list dot map rewrite expression in the context args. If is going to be something similar. Context condition, and then we'll do consequent and else. It's going to be option.map rewrite expression context for the else, and this is going to be consequent. And sequence is going to be list map rewrite expression context. So we just map. It's all very mechanical, just basically walking down anything that is a node in our tree and making sure we call the rewrite expression on that until we get here to the lambda. And then in the lambda case, we want to do something special. So we need to work out what is captured in this context. Find out what is captured. Rewrite the body. So we know how to rewrite the body. So that's going to be locals captures env and rewrite expression in the context body. But that needs to be a new context. So we're going to want something like context it's going to have a parent, which is the current context. And then we need some way to take a sequence expression or whatever and get the captures from it. For expression. Mappings for expression body. And then I think env here is going to be I don't know how, yeah. So just create an empty mapping for the time being. So that should go around and rewrite all the expressions now, and we should be back to the point where it's just the failed hoist things that are failing. And we are 3 tests failing. So I'm going to commit that as is. So we've got the compiler changes where we've basically gone through, and I don't know why it keeps on doing this. Further change, please. interpreter changes because of the new bound syntax tree thing, because we're storing everything on the root of that. And lower and initial lower pass. This pass is responsible for rewriting environment accesses now. The actual not yet implemented. So what have you, no, yeah, that's probably what we want. So we have done the stop allocating, and we are in the process of allocating them in the environment. What's gone wrong here? I think this is a case of the compiler, the Visual Studio Code getting confused because I moved some things. So mappings for expression. I think effectively what we want to do here is well, we might actually know something. Let's have a, it may be that we could calculate this from the captures of the lambda. But I'm not sure. It may be that we need to store, we need to keep track of what is captured in the binder, but just not rewrite any storage for it yet. So if we have a lambda which takes a parameter, and we have another lambda which returns that parameter, that's enough to do a capture. So in the first one we have no locals, yeah, that ties, no captures, that's a pain. So we need to find out a way by looking at this body expression. Let's just print that out on the debug console. By looking at that body expression, how we can, how big our environment needs to be. And also what needs to be in it. So we can just walk through everything in the body. And find out what they capture. Which I think is and then we'll allocate an environment slot for them. thing is, we're kind of already doing that when we bind. No, we'll just do it again here. So we'll do let free equals find free expression. So find free is going to work out what variables are free and therefore captured in our environment. And then we will do something to allocate an environment slot for them. Probably fold of some kind. Find free is a function which is going to say the same as this does. If it's a load, or a store, we don't need to do anything. If it's an application, we need to do find free. It's going to be list, append, find free of the application, and find free of the args. It's not recursive. Well, we can make it recursive. For if we're going to say find free list, right, expecting, but given oh, I see. Found, no. Collect. So this is going to be a list append. Again, it's going to be find free in the condition, find free in consequent, and what's going on here? If we do find free again here, option default value will be the empty list. Is there anything that takes a list of lists? Collect. Concat. Yes. We just do 2 list that appends, I guess. And I'm also starting to feel that maybe it would be easier if we did the appends with a pipe. And another one here. This one is going to be list.collect find free. For a lambda, this is where we actually need to do something. We want to say that the free variables is captures where filter so this is where we'll match the trying to decide whether or not I want to make this a function. I'll say yes is free. We can do that is free function if it is an arg or a local everything else false. So like captures and stuff like that. I don't think we need to know about. So everything that is free, just return that. Everything else just gets returned. Everything else can just be an empty list, I think, because they're effectively things like constants and that kind of stuff. So we've got our list of free variables. Let's try this then. And then we'll try and create a map. That is an awful lot of stuff. What on earth's gone wrong? Indeterminate type. mappings for expression. I don't know what type the AST is. Kind of looks like it's that. Will it run? So we'll have a lambda. Again, which returns another lambda, which returns the original one's argument. If I could write a lambda. So what is free here? Nothing. And then on the inner one, storage ref arg0. Good. So we've got the right free variables. So what we're going to do is, well, we'll do seek dot fold. So what does a fold take? And then we'll do map of seek at the end. So we need something. It takes a folder, some state, and returns a list. So our state is going to be, a folder is going to be for every storage. We'll take an index and a storage. Oh dear. Why have I even done that? Take an index and a storage, and we will return, well, needs to it's not really I think we'll do seek dot indexed, which will take, and then we can do seek dot map, because that's actually all we need. So it's going to take an index and a storage, and it's going to return storage ref environment at that index of that storage. And it needs to have a key. It's going to be storage. Yes, this needs to be I, S because that's taking pairs and mapping it through. Right, so if we run the tests now, we should find some things work again. I think whatever happens, this is going to be done for now. There's a lack of output. What's gone wrong? Key not found. The given key was not present in the dictionary. Yeah. So this is probably because storage ref is not you can't do comparisons on it. So it's doing object comparison, and I think as an attribute. I'm just going to check. F sharp enum val hash key. Don't know, I can't remember, but at least I'm pretty convinced that that's what the problem is. Anyway, I'm going to call it a day at this. So thanks for watching, and I hope this has been interesting. Hopefully next time we can get back on to some more new greenfield development. I'm hoping to be able to tackle macros soon, so maybe it'll be that, or maybe it'll be debug. So adding debug symbols and line information so that we can actually run it under the debugger would be interesting as well. Thanks.